No, it's gone. Thank you. Some of the homework is weird as hell. So if I did have some people ask questions about the weird as hell problems in office hours earlier, I would be very concerned if nobody else has questions about those weird as hell problems. Or maybe you can all handle it. That's a good point. Maybe yeah, somebody just asked me. Oh, no, I just said that earlier. There will be a video for the study guide. Yes, I just have to create it. So hopefully tomorrow I'll get it up. I should have some time tomorrow in between classes. Anything else, guys? Well, I got my second vaccine shot on Friday, and Saturday I was laid out on my couch staring at the ceiling, hating life. It wasn't that horrible, to be honest, but it was worse than I anticipated. But anyway, it's 24 hours it was done. So first one on Tuesday, yeah, they just opened it up to everybody 16 and over. And now now all of you get to love how weird it is trying to find an appointment. So good luck to you.
I heard trying to do it at like midnight's best option.
Okay, I have no idea. I know my little brother got one at Walgreens. So whatever works. Somebody got theirs on Saturday. That was your first shot, Anthony? Second shot. Okay. Did it lay you out, or were you okay? I was laid out, I gotta tell you. Yeah, first day I was fine. Second day I just wanted it to not be true anymore. I was anyway, feeling so much better now. Yeah, exactly. Same thing here. All right, guys. Anything else from homework? We got the quiz on Wednesday. Got the practice quiz up. The solution video will be up tomorrow, is the plan.
I was going to see if you can do a sample problem for I don't know if you can see my thing, this type of formula.
Wait a minute. Let me pin you here. Hold up. Here we go. All right. Where point it again? Oh, sure. Okay. Sure. Hold on. Let me. Bam. Okay. Oh, okay. So, let's make one. Let me turn off my background. All right. Today, computer. There we go. All right. So, let's see how lazy I can be. I can be lazy. I'm up for this challenge. Holy crap. Room? So, if they ask you how large of a sample needed to be within 4% of the true percentage at 98% confidence level. Okay. All right. So what do you guys get from this? I probably need a formula that's solved for what? What letter relates to what it is this question needs from me? What variable?
Z.
No. So what's this problem asking me about? What?
True percentage?
No, it doesn't want me to find the true percentage. Nope, it doesn't give a crap what that is.
Oh, how many is in?
Sorry, a poop. I'm sorry. There's a little person with Q glasses, and I just said a bad word, and I'm sorry. N. So it's asking me how large of a sample I need, and the sample size. That's N. Right. So I know I need a formula solve for N. There's only 2 formulas that we have that are solved for N like that. And this is one dealing with percentages, not means, no standard deviation. So I've got this bad boy here. And I got this bad boy here. Can somebody tell me what E is?
4%?
Yes, so what is it? Not 4%, but it is 4%. But how do I write it? Say again, sorry?
0.04.
0.04, that's the actual number. I like it. What's Z? How do I get Z? What part of that tells me what Z needs to be? I need to look it up.
2.575.
No?
That's 99.
Yeah, that's 99.
98.
If you look at your T-score chart, it'll be easier to find this Z. Is anyone concerned that I just said look at the T-score chart to find a Z-score?
All the way at the bottom.
Yes, all the way at the bottom.
2.326.
Good. Remember, what's alpha here? What is alpha? What is alpha here? You guys are like, dude, we're not even 10 minutes into class and talking about freaking alpha. But remember, who remembers what is alpha? What does alpha mean?
The tails.
Good. Angeline's got it. And you got it. Let me put those together. Then it's the area in the tail or tails. And of course, confidence intervals always make 2 tails. So the area in the tails is 0.02. So you look at the T-score chart, 2 tails, 0.02, and you go all the way to the bottom. Ain't no party like a Z-score party, because a Z-score party don't stop. You just keep going. You don't stop. If you stop, you get a T-score. You want a Z-score, so you don't stop. So you will get 2.326. All right. Is anybody confused about that? Do you need me to show you where that is on the T-score chart?
For me, I thought we wouldn't use it until for the section 8.2. That's why I didn't look at the T-score when I did the homework.
Oh, that's a good point. But now that the T-score chart's out there, it's just another way to find more confidence levels. So
I thought it's just for the 8.2, and yeah.
you're being even a better student than I'm requiring at the moment. So I love it. So normally, yeah, you're not allowed to learn something you learn later. But to be honest, 8.2 comes before 8.3, even though I talked about it afterwards. But still.
I was going to ask you about that question. Like I was saying, why he marked me like not right for the Z-score that it's 1.75 for 96%. And when he said that now, it comes out that we have to look at the T-score to find that Z-score.
No, you don't. No. You don't have to look at the T-score chart. You don't have to. I'm just saying you can. So how do I use the Z-score chart to find the 98%? All right, I love you guys. So this is all trip down memory lane here. Can you all draw a 98% confidence interval for me? Go. I started it off. Okay, so can somebody describe their picture they made?
It's got 98 in the middle, and then 1 for each of the tails. Or 0.01.
Okay, and how do you make the tail? So you're going to draw some...
Draw 2 lines.
Okay.
Yeah, and then it's on the outside.
So if you look up 0.01 on the Z-score chart, you will find negative 2.33. If you don't believe me, do it. You look up 0.01, on the z-score chart, you will find negative 2.33 z-score.
Where was it, or when would we use the z-score chart like backwards? Because I remember a while ago we were
We're
looking
doing right
for
now. We're using it backwards right now.
Oh, okay, we are. Okay.
Whenever I start with an area or a percentage, because those are the same, and I need a z-score, then I'm going to look in the middle and I'm going to look out to see what the z-score is.
Got it.
Okay. So let me show you both of what I just did. All right. Because nobody's speaking up, but I know people out there probably need to see this. Oh, somebody just left. Maybe they don't need to see me even. Shit. All right, let me see. Hold on. Modules. Z-score. Let me do the one we just did. Let me do the z-score chart. Where are you at? There you are. Okay, so 0.01. So if I look up 0.01, that's the closest I can get to it. And that is negative 2.33. Kerbam. Now, if I go to the t-score chart, where are you, t-score chart? There you are. Bisha. Let's see. T-score chart. And I do, okay, two tails, 2% in the two tails. Or if you're like, no, there's 1% in one tail, Jeff. Well, then the 1% in one tail is the same damn column. So, okay, and you can't go wrong. And if I don't stop, I'll get a z-score. Hey, look, there's 2326, which is what 233 is, less rounded. Yes? So if you use 233 or you use 2326, I don't mind. Either way.
But there's somewhere we'll have to use the t-score chart, right?
Yeah, if you need a t-score, you got to use a t-score chart.
Okay.
But any z-score you need, you could use the t-score chart for some, or you could use the z-score chart, right? Okay. So now all I got to do, let's see what we got. Here's my formula I got to use, right? I know Z, I know E, but I don't know P hat and Q hat. Does anyone remember what's the best guess for P hat and Q hat?
Assume they're 50%.
Yeah, 50-50. Now you got everything. Throw it all in the old formula and do it. So we got.
Is that because we don't have n?
Yeah, why did I put a square there? That's dumb, Joe. Yeah, n equal. What's up? Sorry.
If we had n, we would like be able to calculate an actual.
If we had n, the question would never be this.
Okay.
Yeah. The question would be create the confidence interval. So when the question asks, how large of a sample would you need? How many people would we need to talk to? Blah, blah, blah. That's going to be one of the n equals equations, which makes sense because n represents the size of the sample. Okay, maybe. And we talked about where those formulas came from. We actually figured that one out ourselves. So that's not a mystery as to where these formulas came from. Okay, all right, sorry. I like perspective. It's a giant marker. Okay, is that all right? Well, I'm curious what the answer is now. Let me see, can I guess what the answer is? No, I don't feel like it. Why don't I feel like doing that? Because 1400 guys, I don't know, it's like, is it like 98? That's a complete guess. Did anybody do that yet? Nobody did that? What's up with you guys? Nobody did that. Is that true? Nobody's actually doing that? Nobody cares? Nobody's curious?
Did it, but I don't.
Holy crap, I'm way off, so don't listen to me. Oh wait, no, I'm not way off. I am a little bit off. No, I am quite far off. How did you get so far off, Jeff? Just because, dude. That's a good point.
I don't know if I put it in my calculator right, but did you get 845.356?
That's what I got.
That's what I got too.
Oh,
Nice. What did I list? 0.25. Okay. Yeah, 846 basically, right?
yes.
So I just realized I was off by like a factor of 10 in what I did in my head. Guten Job, and Jeff. So actually, I wasn't that far off, but I was very far off all at the same time. Okay. So that would be how large of a sample you would need to take to be within 4% at 98% confidence.
And we'll put 846.
Yeah, you always round whatever you get, you round it up unless it's something exact, a whole number, which would be really freaky if it comes out exact. The probability of that is just about 0. So if that happens, let me know. That's like, I don't know, finding that suitcase from Pulp Fiction and figuring out what's inside of it. It's basically the same thing. If you don't know what I'm talking about, watch that movie. Jeez.
I know what you're talking about.
Good. I personally think it was infinity. Or it was one of the one of the infinity stones. I don't know. This is the same thing. Any other questions, guys? General or specific?
Pulp Fiction is part of the Marvel universe.
Exactly. That's what I'm going for. That's what I'm going for. All right. Okay. All right. So let's get back into.
Can I ask one question?
Sure. Yeah.
It's on the homework 8.3. That's the number, like, you know, the 74 to 77, I think they are, or 75. Yeah. There's like the distribution that we should use. Is it going to be the binomial distribution?
Wait, which number again?
76,
So there.
8.3, section point 8.3.
All right. Poll, blah, 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 blah. Oh, so they do kind of this. All right. We're not going to use the binomial distribution because we need to create a confidence interval. And to create a confidence interval, I need to find a z-score. And I can only use that if I'm going to use a what distribution?
Normal.
Normal. So what they really should ask, and what I need to see, is why is it okay to use the normal distribution here? What do you check for this kind of problem? It's not n greater than 30 because that's for problems dealing with means. Do you guys remember what to check for percentage problems? What do I check to make sure it's normal enough? There's two things.
On 5,
What about 5?
he said, like, do we check it? Like, if we wanted to check it, if it's like greater than 5.
Okay, what's greater than or equal to 5?
The sample size.
No.
The P.
No, P can't be bigger than 5 because that would be 500% chance. NP and NQ. NP is the expected number of successes. NQ is the expected number of failures, actually, which kind of makes sense because Q is the probability of failure. And you want them to each be bigger than or equal to 5, which basically pulls it away from the walls, which makes it have a chance to be normal. Yeehaw. That 7-fingered graph is flipping us off, but we'll be okay. All right. So this is the same idea as this. This is for when I'm talking about sample means. This is for when I'm talking about sample percentages. Okay. Maybe?
So how the formula would look like for the distribution?
I'm sorry, for what?
The formula, how are we gonna look for this distribution?
So are you talking about the formula for the confidence interval?
Yeah, it says like which distribution, like
Yeah.
which formula gonna be what for that distribution?
Formula. There's no formula. It's how do you spell normal? It's normal because, so you got to check this. Does it meet the requirements?
Oh,
Yeah. So you check. It's the same thing as checking this back in the day. Does that, I mean, you guys should be very used to this kind of thing, right? Looking to see if it's bigger than 30. That's only for sample means though. Now for percentages, it becomes this. You have to check this before you can do anything. And again, just to kind of generally remind you guys, I'm going to clear all this away. You ready? It's going to go away. There. If I were you, when I'm sitting down to do homework, I'm going to have sitting next to me the handout that you know freaking Jeff has handouts like crazy. That went over the section I'm doing the homework from. Isn't that crazy? Right? So you can have this handout sitting next to you. Why not? And look up here. Holy shit. I mean, I guess follow what I'm saying. So wherever you did the work for these handouts, have them sitting next to you as you do the homework. If you don't do that, I don't understand you. Can you have them sitting next to you as you do the quiz? Shit, no. But as you're doing the homework, you're not supposed to know everything at that point. You're practicing. So of course you're going to have this sitting next to you. If you haven't been doing that so far, you're not making much sense to me. That's why I do these handouts. It's not just to do them once and forget about them. It's to have sitting next to you as you do your homework to help you. Okay. Sorry. Anything else, guys? Am I missing any chats? Because it doesn't tell me anymore. Oh, somebody got that. Sorry, Corbin. I keep missing what you're saying. Okay. All right. So what I want to try to do, let me see if I can get this activated in here. Hold on. Oh yeah, we got this from last time. Is this up here? Let me see. Yes, it is. Sweet. All right, guys. All right. Do you guys remember this sheet we did like so long ago, last Wednesday? This sheet? Remember this sheet? Did we finish this sheet? Did we do this part? Let me see. Let me double check. I think I got the work we did on it so far. Here it is.
Finished it minus the second page.
Yeah, exactly. Yeah. We did finish it. Okay, good. Good. Guess what I want you to do right now? So what I want you to do, let me put this up here and we can talk about what the hell this means. What the shit? This looks so exciting, doesn't it? I mean, look at that. Just a wall of data. This is actual data, but I think I created this in 2015. So it's not exactly for the last several semesters. It's the last several semesters before 2015. So I don't care anymore. It's just data. So select a sample of 20 grades from the population above.
I see that 44.5.
What is it?
44.5.
You see it?
Yeah, it's a rough
Okay.
one.
Those things happen. 44.5. There's a 49.3. There's also a 97.3. So I mean, it's not all bad. Jeez. All right. So what I want you to do is to do exactly what this says. Please try to randomly select it. So if you have it up on your screen, if you don't want to print it out, just sort of take something, maybe not sharp, and just sort of point it at the screen and then look to see what number, and then do it again and look to see what number. Do you guys understand what I'm saying? Don't go, I'm going to be random and pick 1, 6 and 1, 7 and 1, 8. No, it's not random. That is not random. Not. I'm going to take everything from the first row. Not random. not. You could pick a random row and take all the things from that and then pick another random row. That would be, what would that be, class? If I take a random row and take all the numbers from that row, and then take another random row and take all the numbers from the row, what kind of sampling would that be? Like if I take all of these in this row, if I take everything here and I take everything here, just to randomly, right? I have no idea how many that is. If I keep doing that until I get 20, what kind of sampling would that be? Does anyone remember?
Systemic.
No. And you mean systematic, but that's all right. So I'll give you a clue. It's either cluster or stratified.
Cluster.
Yes. Cluster is take all from some, and stratify is take some from all. Okay, okay. So do it now. Pick 20 randomly. And then do this. Go. By the way, I don't think it's, yeah, I think at some point in the past I did one for males and one for females, and then I had people break up into groups. Now I'm trying to get away from doing any gender related stuff. This is just for people. Let me know if you're still not clear what you're supposed to be doing. You're going to need your T-score chart. Dadgummit. Let me see if anybody yells at me if I do this. Well, you can't. You have to have it up. Okay, let's see. Whoa. All right. No. Oh well, can't do that. You're really careful when you put your data in your calculator. By the way, I am still recording. This is going to be a really... All right, guys. So hopefully everybody noticed that the people you were with had different means and different standard deviations. Yes? Okay. Go ahead, sorry.
I was just agreeing.
Okay. It isn't quite as unlikely as getting hit by lightning twice for two people to get the same 20 numbers from these, but it is very, very, very unlikely. So I did this myself while you guys were in there, and I got these numbers. These are not right. These are just what I got for the sample I picked. Are you guys understanding? So if you didn't get these numbers, it doesn't matter. Okay. Can somebody tell me what the t-score is that you guys figured out you had to use?
This is the question.
What do you mean? What?
Like, is it 1.645 or the one that has the t-score?
1.645 sounds like a z-score. Why can you not use a z-score here?
Okay, why? Yeah.
Because we're using the sample deviation.
Yes. You don't know the population standard deviation. You only know the sample.
Oh,
And
okay.
I basically tell you in the formula, you got to use a t-score. So, but these go together.
Should the t-score be the same for everybody?
Of course, because the t-score only depends on degrees of freedom. Everybody's degrees of freedom is 19, correct?
Yes.
And the confidence level, everybody's confidence level is 90%.
Okay, so I got 1.729.
All right, so everybody should have gotten 1.729. But this number is different for everybody. It might be possible you have the same one there, but erase this, get out of there. And then I've got, so these are mine. These are the numbers I got. The numbers I got are just as right as the numbers you got. There you go, Jeff. So I just want to show you this work kind of done with some sample numbers. I could have done all this too, but oh well, I didn't. Too bad for everybody. Let's see what I get here. 1.729 times 15 point. Why did I round it so much, Jeff? Live according to your rules, dude. I know. Let me see. Maybe 15.053. There we go. Let me be as good as I want you guys to be. So this is 15.053. There we go. 053. All right. 053 divided by square root of 20. Oh, crappity doodah. If I could type, things would be so much easier. There we go. No. There we go. Okay. So I got 5.82 as my error. So my interval ends up being, why are you doing this in your head, Jeff? I don't know. I think it's that, Jeff. Yeah, 74.78 up through 86.42. I don't really ask for it, but you could write the conclusion. We are 90% confident that the interval 74.78 to 86.42 contains the true mean grade for people in the last several semesters, blah, blah, blah. Okay. Now, how do I answer part D? What would the answer be for my interval?
There's not evidence.
Good. There isn't, because this is in there. It could be this. So no, there isn't evidence that the mean is not 80.297. Now, I'm very curious. Please be honest. This does not mean you did it wrong. There's no reason to keep this secret because everybody had a different interval. Did anybody have an interval that did not have this in it?
I did.
Okay, cool. There's one. Keisha's cool. Everybody else got that in there?
I didn't.
All right, there's 2. All right, so let's see. How many people are here right now? I don't know. 29. There are 29 people. Somebody help me out. Now, I really want this to make sense. What percent of all the intervals that we just made should have the true mean grade, which is this? That's the true mean grade of all these numbers. How many, what percentage of them should have that in the interval? Does that make sense? Sorry, 90%. That's the meaning behind the 90% confidence. So what percentage of them shouldn't have? Or would we expect to not have this in it?
10%.
10%. What is 10% of 29?
2.9.
2.9. I would expect on average 2.9 confidence intervals to not contain the real mean. And what did we see? We saw 2 intervals. That's pretty damn good. That's pretty close to what we expect, isn't it? I'm sorry. I really want this to make sense because this is exactly what a confidence interval means. We just had 29 confidence intervals get created. I'm assuming that everybody did it. That might be a big assumption. I don't know. Well, there's one. I'm going to make it 28 because one person has not been here. All right. So I would expect on average about 2.8 intervals out of 28 to not contain the real mean. And we found 2 that didn't. That's pretty damn good. I love it. I have no idea if this makes sense to anybody. If I make a 90% confidence interval, if a lot of people make a 90% confidence interval, I expect 10% of them to not contain the real mean. 2 is pretty close to 10%. What is 2 out of 28? What is 2 divided by 28? Dadgummit, Jeff. Isn't that 7 something percent? 7.1 something? I don't know. All right.
7.14.
7 point what?
14.
14%. Isn't that pretty close to 10%? We saw 7.14% of the intervals you guys just made did not contain the real mean, which is close to the 10% I would expect from a 90% confidence interval. Okay, I really want this to make sense. I'm trying. All right, enough of that. So at least this gave you some practice. Good Lord. What is up with my brain? Brain work. This gave us some practice with the 1var stats, so we don't forget how that works in the calculator, because I'm going to give you problems like that. Okay. All right. Enough of this. Any questions from that sheet? Okay, you're all over the sheet. All right. I am over the sheet. Yes?
So there's no way that we could have done this with a z-score.
No.
Okay.
Nope. No. All right. Because the only way you could have figured out this population standard deviation is if you would have put all of the data on that sheet in your calculator, in which case you would not need a confidence interval, because then you would know the true mean also. Or I could have just given you the real population standard deviation. Does that make sense? I could have just given it to you. But I didn't.
Yeah, that makes sense.
I'm evil. All right. All right. So I want to do a little baby step into the next chapter. The next chapter is chapter 9. Makes sense. The next chapter is kind of big. And I want to point out something that just happened with confidence intervals. Can I use confidence intervals to test a claim that somebody has made? Yes, I can. So, I mean, for example, stay with me now. Let's say that somebody makes a claim. They say, I think that more than half of Americans like asparagus, right? Make that claim. And we create a confidence interval like this. We make a confidence interval, and our confidence interval that we create looks like this. Is that evidence against the claim that more than half of Americans like asparagus, if that's the interval of percentage of Americans that like asparagus?
Yes.
Yes.
That is definitely evidence against. Is it proof that?
No.
You're good. Why is it not proof that less than half like asparagus?
It's not definite
Why not?
because we're only whatever percent confident that it falls between those values.
Sure. Okay, I'll accept that. It's really more the fact that it's based off of a sample, which kind of leads to it being only so confident. So I'll take it. Yeah. All right. So everybody semi with me so far. So I can test claims made by creating a confidence interval. And this has come up a few times where I said, is this evidence against this? Is evidence against that? Okay. And it just did on that sheet. So everybody with me so far? Now, what is this, for example, based off of? It's based off of a sample estimate of a percentage, which is why it technically is not the thing we use to actually test claims. Okay, because it's based off of sample estimate data. No. Okay, so I'm not going to use it to like officially technically test claims. I could use it myself to test a claim I make to myself just to see what's going on, but I'm not going to print it as evidence against a claim in a journal article. Okay, so what do we do to test claims then, Jeff? And is there a better word than claim in statistics? Yes, there's hypothesis testing. Wow. All right. Now, this has some interesting aspects to it. I have many worksheets. I have a full explanatory handout. I'm trying to get you guys to understand. This is going to be the beefiest, and I don't say this to be making you frightened, but this chapter is going to be the beefiest chapter yet. Beefy. Now, when I learned this way to test things, I was shown 8 steps. I have cut it down to 5 steps for you. You're welcome, right? But already you're like, all right, there's 5 steps to every hypothesis test problem. Okay. And the last step should be expected is going to be writing a conclusion. Everybody's favorite thing in the world to do. Like, let me write more conclusions in this universe. All right, I'm here for you. All right, I understand it. Okay, so I want to give a feel for what this even is going to be like. Okay. Say that I create a program to help. So I create a program to help students on their SAT test. Everybody knows. Whoa. Everybody knows what the SAT test is. It's still out there, right? Is it still out there?
I think they stopped doing it for California UCs last year.
There you go. I knew that. To be honest, I forgot that happened in California, but I know there are some states, apparently California is one of them, that are looking at or have already eliminated the need for SAT or made it very optional. All right. In my day, it was like a rite of passage, which, whatever. So I'm going to help them on this SAT test or whatever kind of test. Doesn't really matter what the test is. So how do I test to see if my program works? What would I do to test to see if my program works?
Do a survey.
Survey who?
Students.
Students from where?
Better take an SAT test.
But what does that have to do with my program? I love you guys. So all I got to do.
You could
Yes.
probably, sorry, go ahead. Take like a survey, like someone else said, of the results of the SAT from students that took your program and those who maybe didn't take your program.
We already know what the average SAT score is. We have this data out there, right? It's easily accessible because it's all in one central database. So we have that. So what I can do is basically what Crystal just said. And I think it's sort of like what you guys were getting at, but don't say take a survey, say take a sample. I'm going to take a sample of students that I'm going to put through my program, see what their SAT scores come out to be, and compare it to the national average. Are you guys with me? Now, pay attention. Here we go. You ready? So let's say I get 350 students to enroll in my program. And let's say that their average SAT score, shit, I have no idea anymore. Let's say that their average is 1100. And let's say that the average SAT score period for the whole country is 1081. Can I stop right there and run a commercial saying my program works? It's been clinically proven.
Yes.
Oh shit! How we get in so much trouble? Again, why is this by itself not enough evidence? There's two big things. How do I tell? Why'd you say yes? So I don't want to make you feel bad about saying yes, because it's like your brain just says that number is bigger than that number, Jeff. What the shit is your problem, dude? Right? But so
Looking
why?
at it again.
Sorry.
No, I was looking at it again. No, I think it's no, because we got a sample of people who took it, but we don't know if it actually helped them or not.
All right. So we could talk kind of qualitatively. Maybe the students I picked just happen to be students that would have done this well on the SAT no matter what. Do you guys understand that? There's a chance that the sample I took wasn't really random and they were self-selected students who normally would be good students who probably would have done well on the SAT already. Does that make sense? Okay. Also, you're basing this on the fact that 1100 is bigger than 1081. But how far apart are these is the more relevant question. And what information did I not give you to tell how far apart these are? Standard deviation, exactly. All right, let me stop for a minute. All right, and then the really big problem is the fact that just because a sample, even if they were a perfectly random sample, just because a sample got a higher score isn't evidence by itself that the whole population would get a higher score. I really want this to make sense. So in order for a sample to be evidence that something has changed not only does it have to be, in this case, more than that number, it's got to be more than that number enough. So now listen. If the actual average of every student who took my program was the same as this, meaning if my program did nothing, didn't change their test score either way. Are you guys with me? Whatever my program is, let's say it accomplishes nothing. It doesn't help them. It doesn't hurt them, right? Isn't there a probability that a group would get higher or lower than 1,081 already? Just by itself, just by random variation, yes? I could pick a group of 350 that just happens to be 1,100, and that doesn't mean the mean is different. So I really want this to make sense. Not only would my sample have to be higher than 1,081, it would have to be far enough away, out here somewhere. It would have to be far enough, in this case, above this mean to show evidence that the mean for all these people is actually higher. Because if it's in here, who cares? Who gives a shit? I expect samples to be somewhere in here. So if I get a sample and it's somewhere in there, who cares? Whoop-de-doo, Jeff. So not only does it have to be more, it's got to be more than by enough. Okay, maybe? Does that make sense? Any population that has a certain mean has a certain spread within which it's normal for a sample to show up. Where did unusual used to start? How many steps away did unusual start?
2.
2 steps away, 11. So if I got a sample, if this is 2 steps away from this up or more, that would be evidence that my program did something, because that would be unusual, wouldn't it? It would be unusual. I have no idea what I'm doing. I really want this to make sense. All this shit comes together in this beefy ass chapter. All right. Beefy ass. That's a great phrase for the day. I love it. All right, sorry. So it's got to be outside of the realm where I would normally expect to find a sample to live. That would show, because if this is the real mean for my students, then I would expect the samples to show up in here somewhere. If I get a sample out here, okay, that's unexpected, that's unusual, that is evidence that my program did something. If I found a sample down here, that is also evidence my program did something. That would be evidence that I have screwed these kids over. I have sucked educate. Maybe that's how I get smart. I get kids that suck their intelligence out. Does anybody watch What We Do in the Shadows with the energy vampire? No? Okay, anyway. Now, so one big piece of information that I haven't given us is what is the standard deviation? So what if I tell you the standard deviation? Oh, what's going to be good here, Jeff? Nothing really. That's true. So let's say it doesn't matter. Let's say it's 400. Yeah, that's the lot. Let's say it's 300. Sure. Yeah. All right. Now let's see if we're careful about this. Before I can calculate, now, can somebody tell me, what was that 2 thing somebody threw out earlier? What physically is that? To be unusual, I have to be 2 up and
Standard
down.
deviations.
Yes. So what is the number of standard deviations from the mean? What's another name for the number of standard deviations from the mean to the data point? What's a short way to say that whole thing? Something we can calculate. Something that measures distance in statistics.
Z-score?
Z-score, right? I really want you guys with me. Are you guys sort of with me? It kind of makes sense. You should be able to hang your hat on part of this. I want to show my program does something. I want my sample mean to be bigger than the real mean, than the actual current mean, correct? So far this looks good for me, but I can't say anything because a sample could show up and be higher than 1081 just naturally, just by coincidence. So not only does it have to be more than 1081, it's got to be more enough. It's got to be way up there to go, holy crap. So can I calculate the Z-score from what I know here? Or is there something else I have to figure out first? $300 divided by, right?
350 squared.
Yeah, square root of 350. All right. Whatever the hell that is. Square root of, I'd say, I can't do it fast enough. 20, I don't know, 16.27.
1.603.
Am I off by a factor of 10? No, you did something wrong. Holy shit, I'm really close. Sorry. I should have been like, of course I'm that close.
This 16.03035.
Yeah. Forgot to add an extra zero.
Yeah, see, that's the same thing I did earlier. Off by a factor of 10. It always sucks. All right. Let me stop for a minute. Doesn't that feel familiar? Why did we have to do that? Because didn't we take a sample? Aren't we talking about the sample mean? Don't we have to do this? Now can we calculate a z-score? Yes. What would the z-score be? It would be my data minus the mean divided by the new standard deviation. Oh, this is exciting. What is this? Oh, it doesn't come out far enough, does it? My program sucks. I sort of made that happen because I made this so huge. But what does that come out to be? 19 divided by 16. I don't know what that is. 20 divided by 10 divided by 5 divided by 4. 1.2. 1.2. What is it? 1.16? Is that what that says?
1.18.
Oh, 1.185?
Yes. Oh, sorry. 1 point. Yeah.
If you round it even more, you get 1.2, which I mean, that's pretty good for me. I've done pretty good today. All right. So is that unusual territory? So my sample of students did do better on the SAT test, did they not? They did better, didn't they? Was it evidence? I really want this understood. I'm not making a claim about the sample. Why the shit would I do that when I know everything about the sample there is? There's no need to make a claim. I claim that I have hair. Well, that's good, Jeff. You can see your freaking hair. What a claim. Ooh, way to go out on a limb. So I am making a claim about the population of students who could take my program in the future. I want to be able to say I've shown evidence that it will help out anybody who takes it. What have I met my burden of proof? No. That is where I expect samples to show up. Isn't that about where I expect samples to show up? They only start to become unusual at 2 steps away, correct? So would it be unusual to find a sample of 350 students sitting at this z-score? No, it's not unusual. So is the evidence that my program did something? No, nothing unusual happened here. Go away now. Is that proof that my program doesn't work?
No.
Hell no. Is it strong evidence that my program did nothing? Yes. Whatever, man. I try.
You had the best intentions at heart.
I really do. I sort of screwed myself up by making that so big. Well, I sort of wanted it to be close, but now, all right. So somehow there are 5 steps involved in this complete process. So obviously I have not talked about everything yet. Let me talk about some aspects of this that aren't completely accessible here. What is the claim that I am making in this problem we just did? What claim am I making?
Your program helps students on their SAT test.
All right, I like it. Now, can you say that same thing in less English, more mathish? What would that mean mathematically? What does that mean? Why did this look like there could be a chance? Because my students mean, in order for this to be true, my students mean has to be
2 standard deviations outside the mean.
getting too specific. So I need to show that, all right, let me say this a little bit better. My sample mean is bigger than that's great. My sample mean has to be more than 2, that's great. But my claim is the population of students who would take my test have a score greater than 1081. That is my claim captured succinctly mathematically. My claim is the population of everybody who takes my test will make greater than 1081 on the SAT test. Does that make sense, guys? Guys? Yes. All right. So somebody who is in the background wanting me to fail, what do they think is true? What do they hope is true? How do they feel about this? I mean, what are they going to say? So this is my claim. What's the alternate claim? There's always 2 sides to a coin here, right? What's the opposite of this? Of course, is what I'm saying.
Yours.
Yes? Am I coming through okay? What's going on?
Your
Corbin
set
wrote something.
mean.
Sorry? What?
Corbin wrote something in the chat.
Oh, there we go. Okay. I always forget to look at that. Yeah, the opposite of greater than is less than or equal to. Yes. So I always consider these 2 as being the 2 old guys in a coffee shop. Have you guys remember back in the day when you could go to a coffee shop and sit down? And did anybody ever see like 2 old guys, or it could be an old guy and an old woman, or it could be 2 old women, or whatever. And they're sort of like having an argument about something. Has anybody ever seen that? Anyway, maybe it's just me. So normally one of them, at least one of them, has a newspaper, and they put it down. And they're like, "Well, what about this? Well, you're crazy, man. I should be doing." Well, whatever. So I always think of this as 2 old men in a coffee shop. One of them thinks something, the other one thinks the opposite. All right. So what we call these things, these 2 statements are my hypothesis statements. These are, so this one is, remarkably enough, I have used a horrible word here. I wish I had not used this word. It's too late to go back in time. I can't go back in time. That's a very it's misleading, Jeff. Let me just say other claim for right now. Because there's one called the null hypothesis. And there's another one, holy crap, what word is that? I know. And there's another one called the alternate hypothesis. And of course, I just labeled them completely backwards. The null hypothesis always has an equal sign. And the alternate never does. By the way, let me ask you this. How many tail tests would this be? What side of the picture did I have to show up on? Did my sample have to show up on to show evidence for what I thought? Could it show up on either side and show evidence for what I think? I don't know if you guys remember what we're talking about down here, where if it showed up in here, it was shit. It had to show up where? This was definitely double shit. This meant that not only did it not make it better, it actually made it worse. So where's the only place that could show up to show evidence for this?
To the right.
Up here, right? I'd have to get a sample so far up here that it has to mean that the actual picture would look like this. It would mean that the mean has got to be further up. So this is an example of a one-tail test, which is why the t-score chart is broken up into one tail versus two tail. What would a two-tail test look like if this was mean not equal to? So how can you be not equal to something? You can either be
Ahead of it or below it.
Yeah, you can either be more or less. So that would be a two-tail hypothesis test, is if this guy said not equal to. Okay, I think I want to stop there because I'm going to throw way too much at you. So what we're going to do Wednesday, I'm obviously going to take questions related to the quiz for Wednesday, but we're going to go through more steps of this, and then we're going to go through a complete hypothesis test. I have a worksheet that explains each step, what it means, and what has to go there. It's crazy. All right. And it talks about coyotes. I have no idea if that is good or bad for anybody, but it talks about coyotes. It just does. All right. That's enough for today, guys. So let me know if you need to hang out after. Hopefully that wasn't too abrupt. Stop. Now you guys can go, and I'll see you Wednesday or tomorrow at my office hours. Bye, everybody. Email
Bye,
me.
thank you.
Remind me about the study time.
Bye, thank you.
Did anybody
See
email
you
me?
later.
Yeah, I sent the email.
Okay. Thank you, Nikisha. Oh, Ethan, you good?
Yeah, I just had a question about I don't know if you got my email about